So we will see some exercises and we will find out. Okay. In time ordered data, we will have some practice to really see the causes of variation. I'm going to give you some instructions. You have to use those signals, the 3 signals that I said. Okay, regarding the 14 points, I'm just saying the 14 points alternating up and down. 1 point below, 1 point above, 1 point below, 1 point above, 1 point below, 1 point above, 1 point below. That is the first data point below, the second data point above, the third data point below, the fourth data point above, the fifth data point below, the sixth data point above, 7, 8, 9, 10, 11, 12, till 14. Up to 14, if it touches, that means somebody is adjusting to make sure it is on the center. That is also a special cause. Very important, because they'll say, no, there is a saying, too hard to believe, right? Which means somebody is meddling with the data. Okay. Now, can you all see this graph? Can you all see this trend? Can you all read something? I've just circled it for you. But when I don't circle it, it will be very difficult to observe that. Now, apply these 3 rules. 6 or more points in a row continuously increasing or decreasing. 1, 2, 3, 4, 5, 6. Okay. If you see here, the process, it doesn't any abnormality here. If it is no, just type no. If you say yes, you see yes. Okay. So you see that answer is yes and no, right? The answer is no. And that is why rules, I've deliberately shown this graph, because in a graph like this, how do you see whether it is stable or unstable? That is why these rules are given. Now, if you see the process seems to be stable, if nothing changes, this company can expect anywhere from 1 to 11 major contracts per month. This is the number of contracts. The process, I'm saying stable because, please understand this, it doesn't violate any of these rules. If these rules are applied, then it is unstable. Okay. Now, this is a stable process because there are no 6 points continuously increasing. Though I have circled this, but 1 point has decreased, again it has decreased. Only 3 points have increased. I have deliberately circled this for you to say, yes, there is an instability. Unless 6 points are continuously upward, and unless 6 points are continuously downward, this rule doesn't apply. And unless 8 points are on one side, here, none of the 8 points are continuously on one side. Can you see that? I've deliberately circled all this just to confuse you, okay? And I'm only talking about stability, okay? I'm not talking about capability. Please understand this. I'm only talking about stability and capability are totally different things. Write in the notes. Process is stable doesn't mean it is capable. Okay? Process is stable at a given quality. That quality is not acceptable. Like, for example, you produce burgers, you don't like the taste. Process is stable. They produce the same nonsense every time. All right. Now, that's why I've highlighted these things just to, ask you a question. Now, let us see this graph. No signals of special causes here, okay? This is because we have not put a control limit. There is no control limit here. We are only checking for stability in time order plots. Okay? Once you put a control limit, once you want it to be in a particular, the rules will change. And that is called control charts. Now, from time order data, we will go to control charts. Okay. Now, let us see another example. Okay. Now, see this graph. 8 or more points in a row on the same side of the median, no, but 6 or more points in the row continuously. This is the time order data, and 6 or more points in the row complete. Now, if you see this, and it's very important stuff, without this, our analytical mind and problem solving cannot work. Now, you see 6 or more points here. So there is a signal of a trend, may indicate shift in the process. So it might indicate a shift in the process. Now we have to look to see what was different during that time period. And this is where the investigation should start. If you see examples, there are a lot of rules that people would say, and some of these rules I've just placed in this sheet as a pointer for you to just absorb, okay? Okay, just see this trend and just see, this is all for you to interpret, okay? And this is how your mind should start thinking, okay? I'm not going to give you what is right, what is wrong in this. I'm just marking the signals. It is up to you to interpret. Because of the shortage of time, probably you hear this recording and it will be a homework for you, okay? And now if you start putting the control limits, then the outliers will become visible, okay? Now you have to use the combination of outliers and the combination of the signals. Once you put the control limit, now you will have to use a combination of both. Okay, let's get to this point. So single point outside control limits, a run of 8 points or more. I'm not going to explain the 6 consecutive points increasing or decreasing, 2 out of 3 consecutive points near that outer control limit, and 15 consecutive points or 16 consecutive, some people say 15, 16, 14 and all that, okay? Now, so when you add a control limit to this chart, it becomes a control chart. You start seeing, okay, what is the UCL for upper control limit and lower control limit, okay? And control limits are decided by the process and not by customers, okay, or individuals, okay? But then control limits are decided by the process and not by people. Specification limit is decided by the people, that is the customers, okay? So statistically determined control limits are drawn on the plot. How do you statistically determine the control limits? That's an important point. How do you statistically determine the control limit? Now, when I draw a plot like this, so the basic features are same as time plots, but then you have control limits. The control limits are decided by the process, so it is calculated from the data. There are different views, different formulas, depending upon whether it is the range chart or X bar R chart or individual chart or moving range chart, and there are a lot of things. I'm deliberately throwing all these charts for you to become confident that there are various type of charts that are there. Okay, the center line usually refers to the average instead of mean. So the uses of control chart is this, okay? You can track the performance over time and evaluate the progress. And the progress before the process changes and after the process changes. So we are going to talk something called as process capability later, okay? So this is also help us to establish the process capability, okay? And using these, you can separate out the common and special costs of variation. So points outside the statistical limit signal the special costs. So this is almost, it can be used for any type of data which is collected over time. Now, there are a lot of, the kind of control charts shown on the previous page is called as the individual charts, okay? Because the data points are individual data points. Actual measurement like sales, cost, shipment, cycle times, efficiency, loss in money, maintenance time, chemical costs, pollution levels, production loss time, production amounts, temperatures, pressures, speed, humidity. You can keep on listing all that, okay? Now, if you ask what are control limits, okay? If you see the graph here, this graph, actually, these plots, when it is plotted on a frequency plot, I'm going to introduce frequency plot here. These plots, time order plot, can be converted into frequency plot, and the frequency plot generally forms a distribution called as normal distribution. And these data, if you draw vertical lines, number of points in the vertical lines are plotted here.